All right, so let's take a look at worksheet 2B now. So worksheet 2B has some different geometric shapes, and underneath each one of the geometric shapes, you're given some information to find out from the information provided. So at the top, the instructions are calculate required values assuming a height of 3.6 for anything. Anytime you're trying to calculate volume, you're going to use 3.6 for the height of these objects. So think of what I want you to imagine you're doing is looking down on these objects. But if we were to tilt them in a three-dimensional view or look at them from the side, then the height of all of these would be 3.6. We'll go ahead and use inches as an example. So all of these numbers we can just pretend are in inches. No units have been shown here, but we'll just use those so that we add the correct annotation to our answers. So a perimeter question is asking, what is the distance we would travel if we were to walk along each one of these lines all the way around this shape and get to where we started? So we can get to perimeter by adding the length of each side to each other, and then and adding it all up. So 1.53 plus 1.53 plus 1.75 plus 1.75. Or if you want to simplify things, you can do 2 times the width plus 2 times the length, and you can get the same answer. If we're looking for area, we're looking for what's the surface area of this space here, and we would get that by multiplying the length times the width. Length times width equals area. And then finally, volume. We can find volume by actually taking the number we have already figured out from area, because that's already length times width, and then multiply that value we got times our remaining dimension, which is why it's called 3D, third dimension, 3.6. So 3.6 times 1.53 times 1 up times 0.75 would give us the volume of this object. And that's what you're going to do, is work through these and try to answer the questions. And you're going to use as reference the geometry formulas. So you get to a question about how do you calculate the area of a trapezoid, for instance. You have the reference here to use to determine that information. You've got a formula you can use to calculate that. Or if you want to know, you don't remember what's the area of a circle, what's the formula for that, and you have that right here. So this is your reference. It also identifies what it is that you're looking at. What's a rectangle compared to a square? What are the different types of triangles that we're dealing with? We have right triangles being represented here. We have an isosceles triangle, equilateral triangle, and these triangles up here are triangles that don't have a 90-degree angle, but it's showing you in this picture that we could take a triangle that doesn't have a 90-degree angle, and if we can cut it in such a way to create a 90-degree angle, we might be able to find the answers to some things by using that information, especially if we can measure things and get the answer. So when you're on prints and dealing with prints that are to scale, this is something that we can use to figure out some things if we've not been given exact information we need. For the most part, though, the worksheet you're going to be working with will ask you to provide information given the information you've been given in the problem. So if you find yourself having to do a lot of trigonometry to get that answer, then you can put the answer not enough information. So let me give you an example of that. I'm going to go ahead and take, well, let's start with this one up here. So you have been given the base length of this triangle, and you've been given the height of this triangle. I can tell this is height because the direction that the dimension line is going in is a direct vertical dimension from the top at the very peak of the triangle to the base of it. So that's the height. If this dimension line itself was parallel to this surface of the triangle, that would no longer be giving me the height of the triangle, but rather the length of one of the sides. So because I do have height and base information, if we go back to our reference, you have height, h, and base, then you can calculate your area. So I can get area of the triangle. Therefore, as soon as you can get area, that means you can definitely get volume, because whatever number you get by multiplying 1.35 times 0.78, you multiply that number times 3.6, and that's going to give you the volume. However, perimeter is going to be problematic because we look at how do we get the perimeter. Perimeter equals A plus B plus C, and that means the lengths of those sides. When we go back to our worksheet, we were not given the length of any other sides besides the base. So we cannot determine the perimeter of this triangle using just basic algebra functions. So we would have to write here in perimeter NEI, not enough information, but we should be able to answer the area and volume question. Let's take a look at the very next one here. A lot of people get tripped up by this one because they assume that this corner here is a 90-degree angle. When you are looking at prints, if the 90-degree angle symbol is not shown, it's usually assumed that it is if it's close enough to looking like it is a 90-degree angle. So you can assume that this is a 90-degree angle, and if we do assume that, we can take 90 minus 53.7, 90 plus 53.7 and subtract that from 180 degrees, which is always going to be what the triangle angles add up to. We can get the resulting A value, or angle A. We can also get the perimeter and volume because we can use the Pythagorean theorem. If this is a 90-degree angle, A squared plus B squared equals C squared. So I can calculate the length of the C side and add those lengths up and get perimeter. And the height of this triangle, because it's a right triangle, is the length of this side, and the base is the length of the other side. So 119 times 0.88 will give me my area, and if I multiply that times 3.6 at the top here, then I can get the volume. So if we do assume that that's a 90-degree angle, we can answer these questions. This one's tricky because it's an equilateral triangle. But one of the cool things about an equilateral triangle, and I'll go to the white page here, create a new one. Equilateral triangle has got equal sides, lengths, and the inside angle are all equal. And if we take a hexagon, for instance, a hexagon is 6 equilateral triangles all put together to create a hexagon shape. The length of each side is equal to the radius in the center because it's equal to the length of the inside edges of those triangles. And put all together, you get a 6-sided polygon or hexagon. Now, if I were to take that equal-sided triangle, we'll say this side is 4. That means this side's 4. This side's 4. And we cut it in half like that. We end up with 2 90-degree angles here. By the way, these angles are 60, 60, and 60, adding up to 180. So cutting the angle in half exactly would make this a 30-degree angle here. We have a 90-degree angle here, and we have a 60-degree angle here. So now what we've done is created two 30, 60, 90 triangles. So if I wanted to determine the height this way, I want to find out what that is, I can use the information we know about 30, 60, 90 triangles from our properties of triangles. A, C equals A times 2, and B equals A times the square root of 3. So which side are we looking at here that we know the length of? These two sides here and here. We take this triangle and we turn it around like that. Okay, so we're going to take this triangle and move it, but we're going to turn it around so we look at it in the same direction we've been looking at all the others. 4 is the full length of this triangle. We cut that in half, so that's 2. And then we know that this side here, which is that side, right, is 4. And we're looking for the height here. What is that? So that's B. We don't know what B is. So if I take 2, which is equal to A, multiply it times the square root of 3, I get 3.464. And that's also what I get here for the height of that triangle. So now can I solve for the volume? I can, because I know the height and I know the base. So base times height divided by 2 is equal to the area of the triangle. So let's plug it in. Base is 4 times height of 3.464 divided by 2 equals 6.928 is the area. That's the area. So we'll call this, I don't know, feet squared, the area, feet squared. Now if I wanted to get the volume, 6.928 feet squared times a height, of 3.6 from the top of the page equals what? Let's multiply this times 3.6. Now I've got a volume of 24.941. And I've got to change this to feet cubed, right? So just to show you that volume again, if this is what we're imagining, is that triangle looks like this. And in this view here, we're seeing it from the top. But in this view here, we're seeing it from the side, and that height is 3.6. And that's how we're getting our volume, okay? So even though it doesn't appear that we have all the answers, when we divide that equilateral triangle in half, we have a 30, 60, 90, and then we've unlocked a whole bunch of ways to solve the problem. So the rest of the worksheet, it kind of goes along with that. I want you to answer as many of the questions as you think you can, and we'll discuss how you arrived at your answers. And in some cases, you may think you can't get the answer to something, but please be careful to look carefully, and also take the paper and turn it around, because sometimes just your perspective changes and you realize you've been given information that does help you with the answer. I'll give you a big hint here. This one in particular, a lot of people think you cannot get the area, but I promise you can. So that's what I'll stop here. It gives you some guidance on these two worksheets. Complete those. You can do it by hand, and then you can scan them and upload them to the Brightspace, and we'll take a look at them and see how you did.